Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem spiral matrix 4. I think that's 4. I'm not super good at Roman numerals. Once again, we are solving a spiral matrix problem. The good news is that this is pretty similar to all the other spiral matrix problems, and it's actually very similar to another problem that we solved recently, namely this one, walking robot simulation, solved it a few days ago. And by the way, I'm obligated to mention that this is similar to a Leetcode 150 problem. So if you struggle with this problem, it might be because you have not solved like this first spiral matrix problem before. So I'm actually going to be showing you two solutions. Both of them are actually very similar. They're just like slightly different ways of coding it up. One is going to be kind of the traditional approach that I took with the first spiral matrix problem. It is feasible. The only downside I think of this approach is that it requires copy and pasting like a block of code 4 times, which is a pretty small price to pay for being able to optimally solve a problem, in my opinion. But I know people like to see cleaner solutions, so I will show you the cleaned up solution. But keep in mind that it actually is somewhat difficult. It does have a few edge cases if you want to, follow those dry principles of not repeating yourself. So let's get into it. The concept is that we're given a couple variables, m and n, which determine the dimensions of a 2D grid. And this is what we want to build and return. This is not a parameter given to us. These are parameters given to us, but we have to create the grid ourselves. We're also given a linked list. I know this looks like it's an array, but it's actually a linked list. It's the head of a linked list. We want to populate this grid with all of the values within this linked list. The complicated part is that we want to do it in spiral order. So starting at the top left, we go as far right as we can. Can't go any further because then we'd be out of bounds. Then we go far down as we can. Can't go any further. Go far left, then go back up. And that was one spiral. We can keep going. There are more values. Now we're going to repeat, keep going to the right. Now keep going down. Well, can't really do that, so we stop now. So that's spiral order. But what if there's a mismatch? I mean, ideally, the dimensions of this grid, like this is 3 by 5, so that's 15. Ideally, that matches the number of values within the linked list. But what if there's a mismatch? What if the linked list has more values than the grid can contain? Well, the good thing is that's actually never going to happen. But what if the grid is bigger than the number of values in the linked list? Well, that can actually happen. And in that case, we will fill the remaining values in the grid with -1. So we had a bunch of values. We took this section here, the first 5 values, and put them here. Then we took the next 2 values, put them here. Then we took the next 4 values, put them here in like that order, right to left. And then we took 5 and 1, put them here and here. And then we were left with these 2, which we were not able to populate. Therefore, they're -1. So now you have an idea of how to solve this problem, because I kind of just dry run through it. But in terms of code, how do you actually code it up? Like you kind of know exactly what to do. You just don't know how to do it in terms of code, in terms of variables and loops and things like that. Well, that's what I'm going to show you now. So the traditional approach that I was talking about is kind of a 4 pointers approach, which is at least what I call it. I don't know if that's like the actual term. I'm going to have 4 pointers to define the boundaries of our grid. So a left pointer, a right pointer, and a top pointer, which I'm going to abbreviate with a T, and then a bottom pointer. So the reason for these pointers is this is the simulation that I'm going to do. Going through the values of the linked list is going to be pretty trivial. We're just going to linearly go through it, just following the pointers. So the first value, let's say it's 3, we start here. We're going right. What does that mean? We're going to iterate from wherever our left pointer is right now, all the way up until our right pointer. So we're going to populate the values until we get to the right pointer. We're going to do 3, we're going to do 0, we're going to do 2, 6, 8. And then we're going to stop. Now, the way I've drawn this is actually slightly different from how I'm actually going to implement it in code. And that is only that, like this right pointer, I'm actually going to put it one spot further over here, just because the code is slightly easier to do in that way. But in terms of how we would fill this in, suppose it's our grid. We're going to say the current row that we're in is whatever the top pointer happens to be at. So we use that top pointer, and then we'll have like an I pointer, and this I pointer will iterate from left left up until right, and including the right pointer. Well, the way we code it up is actually not going to include the right pointer because it's going to be one position outward. And then we're going to do phase 2 of the algorithm, going down. But before we can do that, we just filled in this entire top row. So what should we do? Should we update some of the pointers? There is one pointer we need to update, and that is the top pointer. We filled in that whole row, so update the top pointer. Anytime we fill in a row from left to right, update the top pointer. So shift it downward. In this case, that would mean incrementing it from 0 to 1. So it's going to be down here. Now, I'm just going to quickly continue with the simulation. If you think you can figure it out yourself, give it a try. Otherwise, you can keep following along. So now we left off over here. This is where our position is. And now we're going to start filling in, going from the top pointer to the bottom pointer. This is the next phase. So we'll just take whatever values we have, 1, 7, and then populate them going down from top to bottom, 1, 7. Now, how did we fill that in? Well, if you look at it, we're in the top row. So this is where our I pointer is going to be. It's going to iterate from top to bottom, but we're in the rightmost column, right? We stay in the rightmost column, so we put this variable here. After we've done the rightmost column, we should probably take this and shift it to the left. Now we do the same thing going from right to left in that order. And in this case, the bottom row is going to stay the same. We're filling in the bottom row right now. So I'm going to take the values 9, 4, 2, 5, throw them in there. Now that we've done the bottom row, what do you think we should do? Probably update the bottom pointer. We're not going to shift it down. We're going to shift it up though. So now bottom pointer is up here. Well, looks like the two pointers are at the same position. Is that a bad thing? No, we still need to fill in some data. Now, if the pointers had crossed each other, that would probably be bad. But I don't think that's going to happen in this case because it's not like the linked list is going to have more values than the spiral matrix. Now we are here, and in this case, we're actually doing phase 3 of the algorithm, which is going up. So right now we would go from bottom to the top pointer. Now, in this case, they're at the same position, but you can imagine that that's not always going to be the case. This section could have been longer, but for now, it's pretty simple. We'll just fill in a 5 going up as far as we can. And now we've filled in the leftmost column. We're going to shift the left pointer to the right. And now we're going to do the next phase going to the right. We have 0, and then we don't really have any more values. So the rest of these will just be filled with -1. But imagine if we had filled this in, then we would have taken this top pointer and then shifted it down once again, just like we did the first time. So we did phase 1, phase 2, phase 3, phase 4, and then we start repeating. The only difference is we shift the 4 pointers that we're maintaining. So let's code this up now. Overall, time and space is just going to be the dimensions of the grid in the worst case. So that's just n times m. We're technically not using extra space if you do not count the return value, which is generally how we calculate big O time complexity. So let's get into it now. So I'm going to start with a few variables like the 4 pointers I was talking about. So left and right, this is going to be from 0 up until n. Remember that n is technically out of bounds though. So our right pointer is 1 position out of bounds. And we'll do the same thing with top and bottom. So top is going to be 0, bottom is going to be m. And we're also going to initialize an empty grid. Well, I guess it doesn't have to be empty. It can be filled with a bunch of -1s. I'm going to use something called list comprehension here. This is what it looks like. So we're going to have individual rows of length n. And how many rows are we going to have? Well, we're going to have m of them. So we can do something like this. This is a syntax unique to Python. I cover it in my Python for Coding Interviews course if you're curious. I'm not even joking, like this is the actual lesson. I literally cover nested list comprehension, pretty specific example, well, multiple examples, and then, all this stuff. But anyways, now we are ready to actually populate that grid. And then after we populate it, we're going to return it. So how do we know when to terminate? Well, like I said, the linked list is never going to have more values than the size of the grid. So let's use that as the condition. So while the head is non-null, we are going to start populating. We're going to do 4 phases, remember? 1 is going to be left to right. Next is top to bottom, and then right to left, and then bottom to top. So what I'm going to do here is a for loop for I in range left to right. This is going to go from left to right, but not including the right pointer. So it works out perfectly since we know the right pointer is technically out of bounds. And what we're going to do is in this row, the row is constant. We're in the top row. We're going to populate each value in that row. So we're going to use the I pointer here from left to right, and we're going to just set it to the value in the linked list. And then we should definitely shift the linked list pointer head.next after we're done with that phase, we should definitely increment the top variable. We filled in the top row, so let's next time fill in the next row. There is one little bug here. What if we just had one row? I mean, what if the matrix was just one row? Well, we shouldn't need to execute these phases. And not only that, what if the matrix was just one row and we actually don't have enough values in the linked list to populate that row? Well, I'm pretty sure we're going to get a null pointer exception with this head pointer. So in this if statement, I'm going to add a condition, if not head, just return early. Return the result. Don't get the null pointer exception. Now you can see why this is going to require copy and pasting 4 times. This section, we're going to change these variables around, but still we're going to have 4 copies of this part. Now in a real interview, personally, I would think that this is fine, but I will show you the cleaned up solution after this. So I'm going to copy and paste this. And now we're going to do the next phase from top to bottom. So let's do top to bottom. And this, we're going to change only these. We're doing top to bottom. So now the row is changing. We're going to set that to I, but we're in the rightmost column. So we're going to set this to right. Now, technically right is out of bounds, remember? So what should we do? Well, set it to right -1. And then after we fill in the rightmost row, we should probably update the right pointer. We're not going to increment it. We're actually going to decrement it. And I'm pretty much just going to do the exact same thing with the other 2 phases. I encourage you to try it out yourself, but I will admit that these 2 phases are actually slightly harder than these ones because we're going to be iterating in reverse order now. We're going to be going from right to left. So it's going to be like this in Python from right. And we know that we actually don't want to start at the right pointer. So we're going to say right -1, and then we're going to go up until the left pointer. But in Python, this second value is non-inclusive. So we do actually want to visit the left value. So we're going to set this to left -1. Pretty sure I also cover this in the Python for Coding Interviews course, and we want to iterate in reverse order since we're going right to left, so we're going to have a -1 here. That's the step of the range. Actually, now that I think of it, that's covered in the Python for Beginners course, I believe. Now that we're filling in the bottom row, remember, we're going to change this to bottom, and we're going to change this to I. We're going from right to left. So this is that. And after we fill in the bottom row, we should take the bottom pointer and decrement it. Remember, the bottom pointer is actually going to be greater than the top pointer. The top pointer starts at 0. The bottom pointer starts at M. Finally, last phase here, bottom to top. Once again, this is going to be iterating negatively. So I'm going to change this to bottom. Bottom is technically out of bounds. So actually, now that I remember, this bottom here should have a -1 because bottom is out of bounds. So we want to make sure that this is in bounds. And then this is bottom -1, and then this is going to be top -1. We are going in reverse order. This stays the same. We are in the leftmost row. This will be I, and this will be left. And left is inbound, so we don't need to put a -1 here. And after we do the leftmost row, we can go ahead and increment the left pointer here. So this is the entire code. It's very repetitive. It is slightly longer than the next solution I'm going to show you, but I do believe it'll work. Well, it would work if I didn't make such a sloppy mistake using grid here, but using result for the return value. And I never declared a grid variable, so I'll just change this to grid here and here. And I think we also can change it here, here, and here, and here. Sorry about that. But now you can see that this definitely works and it is definitely efficient. But how do we get rid of this repetitive code? Well, it's going to be very similar to that robot problem I was talking about at the beginning of this video. Obviously, the main difference between these loops is where they are iterating, right? We're either going left to right, top to bottom, etc., etc. There's 4 possible directions that we're traveling in. Those directions could be summarized like this. The first one is moving to the right. The row is not going to change, but the column will be incremented by 1. The next direction is moving down. The row will be incremented by 1, but the column will not change. The next direction will be moving to the left. The row will not change, but the column will be decremented. And lastly, moving up is when the row is decremented and the column stays the same. So now we have the 4 directions, and I'm going to have a few more changes because I want to now maintain what is the current row and column that we are at. So I'm going to have variables for that. And at every step, I'm going to update these variables with the direction that we are currently moving in. So I'm going to maintain what is the current direction. I'm going to use D for that, and it's actually going to be 0. So this is the current row, column, and direction. D is actually going to correspond to an index within this array. I'm going to get rid of 3 of these loops now because we want to eliminate this copy and paste work. We want only 1 loop to handle it, and we are going to parameterize, I don't know if I'm saying that right, but we're going to do that with this using these variables. So initially, I'm going to say, what direction are we moving in? I'm going to get that. I'm going to call that DRDC, and I'm going to get that from directions at D. So now what we're trying to do here, I'm going to leave this code here even though we're not going to be using it, but it does serve as kind of an example of what we're doing. We're moving in a certain direction, populating the grid and updating the current pointer within the linked list. So now that we have these, we want to do the same thing. Let's start by saying while the head, so that we don't have to like have an if statement in there, while the head is non-null, set the value within the grid to this row column. So head dot value is going to be set to this. And then we can shift the head pointer. And also we can update the row and column using DRDC. The first time it's going to be 0, 1. Therefore, the row is not going to change, but the column is going to change. It's going to be incremented by 1. So this is going to be R plus DR, C plus DC. So this loop, the first time around, it's going to go as far right as we can. The next time around, it's going to go as far down as we can, etc., etc. But there's definitely a problem. There's multiple problems. Right now, it's not going to go as far right as we can. It's just going to take every single value in the linked list and just fill the first row with it. So we need to do a boundary check. We need to make sure that we stay in bounds. Let's add that to the if statement here. While head and while we are in bounds. Let's make sure that the row is between left and right. Technically, right is out of bounds, so we can just check that it's less than right. And let's check that the column is greater than or equal to top. Remember that top starts at 0 and is less than bottom, which remember starts out of bounds. Okay, while this is the case, we're staying in bounds. That's lovely. But there's just one problem. Imagine that this is the row that we're filling. Like this is the first row. We have 3 positions. We do this one, we do this one, and then we do this one. Well, there's actually a problem here because this loop is then going to take our row and column and increment it 1 more time until the point that we're out of bounds now. And then we're going to start the next loop and we're going to go down. And the reason we're going to start the next loop differently is because every time one of the loops ends, we want the next direction to start. We can do that with D. So D is going to be set to D plus 1. We want to make sure it's a valid index within this array. So we're actually going to mod this by 4. This will handle changing the direction, but this code on the last iteration will still take us out of bounds. The fix for that is this. Right before we change the direction, use the original direction to undo this work, undo the last operation that we did. So I'm going to copy and paste this and then put it here. So this is just an edge case that you have to handle to get this solution to work. And I think there are other ways of handling it as well, but this one is pretty intuitive to me, just undoing the last thing that we did. It's not a big deal. So here we will minus this, and here we will minus this one. One of these are going to be 0, so this won't really do anything either way. But whichever one is positive or negative, we will undo the work that we did here. Now, there's one more issue, actually. So imagine now that our grid looks something like this, and I'll make it 3 by 3 just to make it more interesting. Imagine we fill in the first row. We do this, this, and this. And then we go out of bounds, but then we undo the work, so we leave off here. Okay, then we're going to go back to the outer loop, and then we're going to come back to the inner loop, but the direction is going to be different this time. Now we're here, and we want to move down. But remember, we left off here. So the first value that we try to populate is going to be this one. We're going to overwrite that one. We don't want to do that. We want to start from here. We filled in the first row starting from here, here, and here, and now we want to go down here and here without replacing this one. How do you do it? The easy way that I'm going to choose is here, after we update the direction, I'm actually just going to copy and paste this, down here, and then I'm going to use that direction to update the row and column using that direction like this. Just copy and paste that. What that'll do is after we fill in the first row, we will increment 1 time to be down here. And then we'll populate this, and then we'll want to fill in the bottom row. But before we do that, we will shift in this direction. Like that's what this thing will be responsible for. So that's pretty much it. But there's one last thing that we're actually missing. Now that we don't have the 4 pointers anymore, suppose we fill in this row, we fill in this column, and then we fill in this. Now we're going up. Well, we're going to end up going here and then back to this one. How do we know that our boundary has changed, that this is the last one in this column? Well, we could have 4 pointers for this. Like we do have our 4 pointers here, left, right, top, and bottom. We're just not updating them anymore. We could update them. It's a pretty easy thing to do. I think we would just need 4 if statements. Like, for example, if we're at the first direction, we're going to increment the top. But rather than having 4 if statements down here, there actually is a more elegant solution. And it comes from the fact that there's actually a constraint on this problem. If you scroll to the bottom, the linked list is never going to have negative values. But we are initializing our grid with all negative ones. So we will know that we're reaching a cell that has already been populated if here we check that the grid at this coordinate row column is equal to -1. Actually, let me reword that. If it's equal to -1, that means it's available for us to populate. But if it's not equal to -1, then we should immediately exit this loop because we have reached the boundary. We have reached a cell that has already been populated. We don't want to overwrite it. So that's pretty much the approach covering all of the major edge cases. I think it's about 10 or 15 lines shorter than the previous solution. Okay, unfortunately, I had a very silly mistake, which to be honest is very easy to make with these matrix problems. So in this condition here, between left and right, we should be checking for the column. And from top to bottom, we should be checking for the row. Sorry about that. Now you can see that this does work and it's very efficient. The main benefit of this solution is that it's slightly shorter, and hopefully you learned something. Check out Leetcode.io for more, and I'll see you soon.